Okay, so good afternoon, everyone. It's 1:30. Welcome everyone to COM 2160, and we're starting today a new topic called garbage collection. So hopefully you guys are doing okay with this COVID situation. So still like the Winnipeg situation is kind of better than the other province. So if you look at the other province, the Ontario, the Quebec, Alberta, even BC, they are kind of increasing very rapidly. So for here, still we are in kind of better than them. So I will request everyone to stay safe and maintain the social distance, 2 meter or 3 feet, right? So, and if you don't need to go outside, just be inside your home. I know like it's kind of tough, sitting idle or doing the things alone inside your home, but we have to do that to, to overcome this situation. The situation is getting really hard. So if you look at the whole world situation, it's kind of so far around 20,000 death. Italy, Spain, kind of very tough situation right now. So hopefully you can see the slide okay, right, and hear my sound perfectly okay. Maybe someone can chat or just let me know whether everything is sound okay. Where is our chat box? Previously we had a chat box. Uh, Let me see. Yes, I got it. Okay. So sites and audio is good. So okay, we can start. I think. How is your lab 6 going on? I think the very first lab he couldn't join by Cisco WebEx, but after that he joined via Cisco. Like he's available via the WebEx things. Uh, so lab 6 basically is a very easy thing if you will just read the question. So hopefully it will be all right. And so we have the assignment number 3 deadline very soon. So unless you have a medical condition, I cannot extend this one because we have assignment number 4 coming up just after this, and we don't have enough time before our final to finish it up. So that's the thing. Your volunteer deadline is still April 13th, so you can you have plenty of time though. You will get the mark assignment 3 also hopefully. So you have time to think, like I think to do the VW or not. Is assignment 3 just a linked list? Uh, is assignment 3 just a linked list? You can think like that, but in C, right? Not so basically in C, a linked list also. You have like kind of an interface, and you have kind of implementation, and you have another main file to test, right? So we shouldn't just call it a linked list, rather than you should get the knowledge of the interface and implementation things, right? So in the main function, the user just testing, right? So he or she doesn't know anything about the implementation details. That's another main thing we want to focus in assignment number 3. Does that answer your question? Maybe. Okay. So we can start. So last day, what we learned about bit manipulation, that is when we are using or abusing the bit manipulation to optimize for space optimization mainly, right? How we can use the bit fields in C. Then if you can remember, we explained the purpose of a void pointer and how we can use a void pointer in a C program, right? Okay, so those were the topic of the last class. So another question, is it called a container because the user only needs to know what it holds information and not how it works? Kind of. If you look at, so you know that whatever the implementation, like the function you have, those are actually we're just having inside the interface also, only the function name, not the implementation detail, right? So those are the things like you can only have inside your interface, right? So I am again requesting you all, like if you have any question regarding the assignment, we can do it offline, like maybe after the class. Since I missed the Monday's office hour, you guys can contact me after the class up to 3:30 or 4 if you want. If you have any kind of problem, you can. I will just keep some. I will just create some appointment. You can take some appointment also if you want today. Okay. So let's focus on today's topic. Again, I am requesting you all. If you have any question regarding the assignment, you maybe I can just read the very last question. When we use delete or insert function, do we need to call first item in them to update the reverse node? These things actually, it's all depends how you are testing. So you have to be very careful, like read those paragraph whether it mention about your main file, right? Okay, so if you need to do, you can call, but if you don't need, the implementation can be there, right? Hopefully it will, like it should work properly, but it's not like the user, like from the main file it will be called or not, it's not certain, right? It depends, uh, depends upon the test you are doing in the main file. Okay, is it clear? Anyway, so we can talk after the class, or or in the office hour. Okay, so let's concentrate today's topic. Okay, and this is important because these topics are related to your next assignment, that is assignment number 4. So you need those idea. Okay, clear? So today what we are going to learn, at first we are explaining the purpose of garbage collection. Then I will describe a simple garbage collection memory manager. Okay, then we'll see like what is called the memory fragmentation, and then what is double buffering to do the memory fragmentation. Then we will go for implementing a different algorithm with the double buffering in C. Okay, so let's see how much we can cover today. So the very first thing, okay, so we already learn a lot of things in C, right? And that is different from Java and Python, right? So maybe we already tried kind of string things. We manipulate in our own function of the string things, right? We kind of also know what is object, like in sense of structure, like it's kind of giving us the feeling like we can create some instance of structure, and it's kind of giving us the feeling of objects, right? But it's still there are many things we are still missing. Okay, so I will request everyone just take some time to think like what is still missing in C. If you compare with the Python or Java, you can chat, like you can give your suggestion in the chat box if you want. For sure, yeah. So it's a very easy thing, right? Because today's topic is garbage collection. Yeah, garbage collection is still missing in C. What others we are missing in C? Any other suggestion we are missing in C if you compare with Python? Java? Should I unmute all, or is there anyone to speak with me now? Maybe I can just do unmute all if you don't mute yourself. Anyway, I think we can continue. So just I got just one suggestion from Matthew, is that is garbage collection. But what about polymorphism? You know, the inheritance. Can we do that in C? So not really. Yes, we cannot do it, but we'll see. Those are for objects for sure. We'll see in the very last topic. Like, still we cannot do it properly, but we will have a flavor of those. Okay. like the inheritance and polymorphism. We have a bypass way to do those. Okay. And what about like graphical user interface? You have in Java you have Swing, right? In Python you have the TK library. You can use that one to uh, support the GUI, right? If, what about in C? We haven't seen anything like that, right? Still. So maybe in this course we are not going to see, but still you have the GTK call library to work with those GUI in C. Okay, so let's focus on this topic, that is garbage collection. So you can just read this definition from Wikipedia actually. So in bigger sense, what is garbage collection? So in computer science, garbage collection is a form of automatic memory management. The garbage collector or just collector attempts to reclaim garbage or memory occupied by objects that are no longer in use by the program. Very long line, right? So in shorter form, we can just say like whatever the memory you are not using but you already allocated, you should be free it up, right? That's the garbage collection, right? Okay. So what actually making garbage, or how we can make garbage, right? So suppose whenever we are saying malloc, right? Whenever we're saying fopen, right? Okay, so some memory is allocated, right? So if you compare in Java, whenever you use new, some memory is allocated, right? But Java has its own garbage collector, not like C, right? So in Python, even whenever you are opening a file, some memory is allocated or your resource is allocated, right? So that's why it's very important whenever you use fopen for opening a file, you should do fclose or those kind of things. So we are using the resource for sure, and then being finished with the resource, okay, and maybe cleaning it up. So that's the thing, like we are saying maybe cleaning it up. So if you don't clean it up, it makes garbage, right? So if you clean it up, then the garbage is collected. So something like that. Okay. So in garbage collection, actually, we are automatically freeing up the unused resources, right? Okay. So we are saying here automatically, right? So so it's not there in C, but can we do something that will be done automatically to just like Java or Python? Okay. So we already know that the Java, Python, JavaScript, Google's Go have the built-in garbage collection. But for C or C++, we don't have such facility, right? Okay. And we also have another programming language called T. Okay. And there it's optional. Like it has the option. You can like turn it on or turn it off. Okay. It's your choice. Like it has the option, but by default, it's just like turned off. If you need it, you can turn on. So some programming language you can handle it, like whether you need it or not. Okay, clear? So any questions so far? Clean up the heap memory. Yes, for sure. Whenever you are having the stack one, whenever you are out of the like that uh, in our very first lecture, so we draw some figures in the board, right? So we saw that whenever it out of scope, it just clear it, right? But for heap memory, there is nothing we are doing so far, right? Yeah, yes, you're correct. What does C not have? Why does C not have garbage collection? Are there any advantage to not having it? So Matthew asked that why does C not have garbage collection? Are there any advantage not to having it? What do you think? Do you have any answer in particular? So if you, yeah, so that's the, so, and I will come to that question later. So and so Kotlin asks, like, if you do not clean up the heap memory, what happens when you end the program? It will be there actually. It consumes the memory. There is nothing. It will be automatically freed, right? In C. Okay, clear? So why does C doesn't have garbage collection? Because C is kind of very old language, you can see, and sometimes you know that uh, in C we're doing the memory management things like compared to the Java or Python. Those programming languages doesn't have any pointer, right? But we have a pointer, and the memory things is handled by us. So C doesn't know like how you have created those, like the dynamically allocated memory. It doesn't know like how you have done that. So it's totally your design, right? How you have done that. So that's why like you need to do that by yourself. Okay. So the memory things you are controlling. So you should deallocate the memory, or whatever you like, any resources you are not using anymore. Okay, so C cannot actually trace these things. Okay, you can write code to trace those, like whatever the resources we are not using anymore. Okay, is it clear? Any more question before we go to the next slide? Okay, so we have some kind of algorithms to work on the garbage collection. Okay, so there are three actually. One is tracing garbage collection, and there is escape analysis, and there is reference counting garbage collection. Okay, so so we are not interested in number one and two. So there will be no question or anything about like how we are doing tracing garbage collection or escape analysis. We are only focusing on the third one, that is reference counting garbage collection. Okay, so we are going to implement a memory management system with a reference counting garbage collection. Okay, and this idea we will use it in the assignment number 4. Clear? So let's see, okay, how we can design it. Okay, so there are two main things. One is we have some ground rules how our memory manager works, and then we have to be careful what the memory manager needs to know to do the garbage collection. Okay, so let's describe the very first one, like what are the ground rules for our memory manager. Okay, like what are the things we need to know. So for sure, clients or user will call our function to allocate the memory, right? Like maybe so the user will just can say like create object, right, in the interface file, right? Like starting any name dot h or something, right? Like the header file. But in the implementation details, that is how we are going to create that, right? So whenever the user is saying like create object, for sure in implementation, if you are using the dynamic memory allocation, you are using malloc there, right? Okay, so client will not call any malloc, rather than client will just call a function, right? And then our memory manager should automatically clean up the unused memory. So this term, the unused, this is important. If you are using the memory, you cannot delete that. If you are not using the particular resource you allocated before, only then you are cleaning that memory. Okay, so you have to trace it, like which memory you are using, which memory you are not using, right? Clear? So now my question is, when do we collect the garbage, right? Or when should a memory manager collect the garbage? Any suggestion from anyone? at the end of the program for sure. And what are the criteria, like what you should look at when we need space? For sure, yes, that's one criteria. When we don't have access to it anymore, it's kind of same thing when we need space, right? When we need memory actually. So I am okay with all the answers. When if it is not used later in the program after using it, for sure, yes, that's the main thing, right? So whenever you have to very careful that uh, so you declared some resources and the very end of the program you are not going to use those, right? And then you have another thing to do, you need more memory, you cannot allocate those, right? Because there are some unused things, you should clear that up, right? Clear? Okay, so now the second point, what does our memory manager need to know when garbage collecting, right? Okay, so it needs all the objects that is managing, for sure the existing object, right? So which of the objects it should collect? Okay, that is the unused object. Okay, and which of the object it shouldn't collect, that is currently in use object, right? So it's kind of like the memory manager should know everything, right? So what are the existing uh, object here means like kind of like declaration of variable, declaration of memory allocation, like that. Okay, so what are the things we already declared? What are the things in those declaration are in use, and what are the things in those declaration are not in use? Basically that. Clear? So what is in use? How we can know that, right? So our memory manager handles memory allocation. A client will call our function, like I said. Okay. We can keep track of the references we have given out. So whenever we declare something, right, then we are for sure we are going to use it. So that means actually reference. So you declare a variable and then that variable you are calling again to do something, that's called a reference, right? So by that actually we know that whether a particular memory is using or not, right? Okay, what about if it is not in use? How do we know like what is not in use? Any suggestion? Can anyone answer that? Is there any way we can know, we have any idea like what is not we are using? There is nothing referencing that object for sure, but whatever we are having in SMR 3, you know that we have kind of clear and destroy things, right? Right. So we have the clear things, we have the destroy things. So in destroy, like you are kind of free those things, and in clear you are kind of just delete those things, right? So whenever we are not using anymore, right? So whenever you know that there is nothing referencing that object, yes, that answer is correct. But in which cases we are doing that? So whenever we are declaring some variable, we are referencing that, we are using that, and after that maybe we are just deleting that or we are no longer using that, right? So that code is also written by the programmer, right? Or whenever we don't need that, suppose in a linked list, right? Sometimes we delete a node, right? So whenever you delete a node, right, it's not like the memory occupied by that node you are destroying, right? It's just you are not, you, so it's something like you are just pulling a line from the previous node to the next node rather than saying the deleted node, right? So it's just like we don't need it. We just uh, like updating our link, nothing else we are doing, right? So in those scenario, actually we know that that node we are no more using it. We can just free those space. Is this example clear? Okay, so that's how we can know like this is not longer in use. Okay, so what Java basically does, right? Okay, whenever you are using any new keyword, right? Okay, so it creates some space. Okay, and it hooks the stack variable. You know that whenever it goes out of scope. But what about in C? We have the malloc, right? Can we just hook into malloc so that we can know like when it is in use and when it is not in use? Okay, we can do it. So, Tahmida, so like freeing the space when dereferencing a node for sure, yes. Okay. So we'll see example. Uh, Another question, so we free the memory after deleting the node in the delete function. Uh, so it's kind of a tricky question. If you implement the garbage collection, then yes. If you implement the automatic garbage collection in C, then for sure, yes, you need to free those things, right? Any more question? Okay, so looking back to the slide, like we are saying that how we can hook into malloc in our C language, right? Okay, we need some actually nasty hacks with the linker. So what we're going to do here, like we are having a public, we are going to declare a public interface, okay, a function requesting the memory allocation, and then function for requesting memory that was already allocated at to a counter, and the function for telling the garbage collection that we are done with this memory. Okay, then our implementation will use the counter for memory allocation to decide if it can be collected or not. So it's so okay. Another question I got a bit off topic. What will be the format for the finalizer? Okay, so I already discussed. So if you listen the last video lecture of Friday's one, you will get the idea. Or so in the middle of the slide, you shouldn't ask this kind of question. You can just ask after the class, right? Okay, I will let you know. I will also discuss after the class today, like what kind of format it will be. Okay, clear? So back to the slide. So what we have actually like this counter actually you can also think as a reference. Like whenever you have something declared and you are using that, the counter goes up, right? And whenever you are like kind of you are not using anymore, that counter goes down. And whenever like decrements the number, right? And whenever you see that that counter is like the reference is no more using, you can yeah call the garbage collection things, right? Okay, so it's basically it's called a mark and sweep algorithm. There are two phases in it. Like at first you are going to mark the objects you know about, and then you are going to recursively mark every object that is being used. Then whatever the objects is not used, you're going to delete it. So let me give you one example here. So for each of the cell, like it's kind of like if you just draw a picture, whenever you are using some kind of traceback, like some declared function or any variable is using anywhere else in the program, you can just draw a line, right? And then that's the marking things. Okay, starting from the roots means starting from the main function, right? Whenever it calls, right? And the sweep phase is return all unmarked cells to the free list. Okay, and then there's reset the mark bit on all marked cells. So it's something like whatever is not using, you are deleting that, and whatever you mark, you just reset those. Okay, so just like this. So at first, suppose the left hand side you have the root or the main function, right? So it can call different functions or different reference, right? So pointing these arrow, right? Okay, so these are already declared in the heap space. Like maybe these are the implementation details. Like you know that this is kind of a using main function, using interface, so the user knows like what are the interface available or what are the prototypes available to call, and these are kind of inside your implementation details, like you created those, right? So whenever you call the main function, these are the references so far used. Okay, they there can be interlinked, right? And then like the algorithm says at first mark all the things. Okay, so whatever is using, like these are we are marking, right? So from here we goes here, we mark here, from here we goes here, and from here also it goes here, here as well. So we mark there those things. Okay, then what we are going to do, you know that there is no marking here, right? So we just dump it using the garbage collection, and we reset all the previous marking. This is how the mark and sweep algorithm works. Clear? Any questions so far? So what we are going to do, actually, we're kind of using a public interface. Okay, and then you are going to implement a mark and sweep kind of these things. Actually, this is more about the assignment number 4. Okay, I will describe it later also. Okay, so in the implementation detail, save, and it executes the garbage collection when the memory is exhausted or whenever any resources is not needed. Clear? So what we are going to do here, we are going to implement a abstract data type like the object manager to simulate the heap memory. Okay, the object memory will be maintained in a buffer of generic memory. So you can just think about this buffer as like an array of bytes. Okay, so what it does, actually, we maintain a linked list to keep track of all the objects that have been allocated. Okay, each of the node is a structure that contains all the record information about the allocated block, like what is the start or offset. Okay, so so I got a question here. So whenever we call the function, the algorithm is called with the function to mark the currently used cells. So whenever we call the function, which function you are mentioning? Can you just type Adrian, I think. Oh, so that mark and sweep algorithm, whenever you call the function, the algorithm is called with the function to mark. So it's actually not we are going in the particular implementation details of the algorithm of mark and sweep. It's kind of we are, for now, we are just having the idea like how it works. Okay. So should we call GC every time we are done with the function? Like you mean the previous slide, like so here, like you can see that executes the garbage collection when memory is exhausted. Like suppose you are kind of you want to use some memory, but you cannot use that, right? Like it says that you have to free it up or something, right? Then only you have to use the execute. Also, like if some points, like we will see one example. Okay, if we see that some resource already allocated, we kind of delete those resources, and it's no more using that resources, then also we are calling the garbage collection. Okay, is it clear? Adrian and Min Sankim. Okay, so let's back to the slide. Okay, so so we are talking about this buffer. Okay, and whenever it's kind of a linked list, whenever it's just keeping track of all the objects we are allocating, and it has a property like a start or offset. Length is the size, how much length we are allocating. Okay, count is like the reference count, like I said before. Okay, and at the very last, that's just kind of the identification of that particular linked node. You can unmute yourself if you don't have anything to speak. Okay, so what we are doing actually, to request memory for an object, we reserve the next block of free memory from the buffer and add new item to the end of the linked list. That is how the linked list works, right? Clear? So so suppose for an object we are requesting a memory, we'll reserve the next block of free memory for sure from the buffer. Add a new item to the end of the linked list. So that is how we are doing. Okay, suppose in my interface or in my main method, I have a code like insert object and I am giving 10 bytes. Okay, so how this buffer will be updated then, right? So you know that the ID is 1. So just like we are having the we are having like for each of these object we are having an ID, something like that. The size is 10 because we are having 10 bytes. Reference count is 1. Okay, and offset means the starting position is 0. So now whenever the next function call, we have like the insert object with 16 bytes, right? So what is happening here, we are just allocating the memory after just the previous one, right? Okay, so it's just a linked list. So another node is created with ID is 2, size is 16, right? Reference count is also 1, like we're just calling this one time, right? Offset means like where it is start. Clear? Okay, so the garbage collection in this example is a simple version of mark and sweep algorithm. The marking occurs throughout the life of an object by using the abstract data type methods to change the reference count of the object. Okay. Once the reference count for an object reaches 0, the object is considered garbage. Okay. So suppose here you can see that we are having the insert object, right? So when so that's why the reference count is 1. So what when it will be reference count 0 then? Any idea? So maybe we can just say drop object, right? Right. Then drop object for, so maybe so this is like not the complete line. So if I say like some reference equal to or some variable equal to then something, we can just say that we can just drop a particular node or something, right? And then that reference count will be 0, right? So whenever we have that, we can consider it as a garbage, right? Okay, so that memory cannot be reused until we clear it, right? So whenever we have this memory allocated, right? Suppose these red blocks we are not using anymore, right? So this memory is already allocated, right? So if we delete this, it is not deleting from the original memory, right? It's just like links are updated, right? Okay, so will there be an example code where marking? Yes, I will show it soon. Okay, clear. So that's why like whenever we are not using any kind of memory portion, we have to call the garbage collector. Okay, clear. So suppose here I can give you one example. Okay, so the previously you saw that we have kind of one by one we are just adding, right? So now what is happening here in this slide, you know that we have the ID number 1, right? And then I have ID number 3. So you know that previously the second node we just deleted, right? Okay, but it's already there in the buffer, right? But it's kind of there, but it's not using. That's why we are saying it's free. That means we are not using that. Okay, so that's the problem, right? So we are having our in our buffer like only one number, block 1, block 3, and block 6, and there are some unused portion, right? You cannot use those portions, right? Because you deleted those. Is it clear? Like that's why we're saying that object manager after multiple allocation or deallocation. So once we allocate the memory, we deallocate those memory, right? But it's unused, but resources is like also, resources are used, right? Clear? Is it clear? Any other questions so far? Okay, so now we'll see one example. Okay, so here this is the interface we're talking about. Okay, so you can see that we have at first this is the header file. We define the memory size, right? This is 512 kilobyte, right? So how we are doing this, like why we are doing this? So if you do like this, also there is the option like you can change it. Like whenever you run the code, you can change it. Just you have to use slash or hyphen d, and then you can use this variable name, and you can mention any size. By that, whenever you are running a program or using this header file, you can change a particular variable's value. Okay. Uh, so someone says that you can zoom in by yourself. I'm not sure what is that. Anyway, okay. So what we're doing here, we are using unsigned long variable. We call it reference. We're having unsigned long variable, we call it ulong, and then unsigned character uchar. Okay, and then what we are doing here, like I said before, the very first one is we are kind of inserting object. Clear? And it will give us a reference. What is reference? A kind of a long number. Okay, so why we are taking unsigned? Because we are not dealing with any negative number, so we can just have the unsigned here. Clear? So whenever we are inserting object, it gives us a kind of like a long number, like where did you put it, something like that. And then for retrieve object, we are using that reference to retrieve it. Okay, so kind of an address, memory address, right? Clear? And then we have other methods or functions, that is add reference, then drop reference. Clear? So that is what we are saying, like we can also drop some reference, add reference. We have the init pool, that means that what is the current like initial situation of our object manager. So just we saw that buffer things. Okay, and then we can destroy it at last. Okay, whatever the dump pool, that is traverse the index and prints the info of each entry corresponding to a block of allocated memory. It's give you a summary after dumping. Okay, clear? And now this is the interface, and we have a main file also, right? And what we have here, at first we are using this insert object with the size 100, right? Okay, then we are kind of having a for loop. Then we have another reference, right? We are calling this insert object with the size 4000. Then another reference. Then we are dropping reference number 3, okay, then adding reference number 2, okay. So we'll see like how these things are working here. So this is kind of a diagram for init pool. That means the object manager, okay, the buffer things, how it's actually represent in your memory. So what we're doing here, at first the reference is 1 for sure. Because this is a linked list, we're saying it's kind of working like a linked list. The head is at first null for sure, right? Okay. So free pointer means like where we are currently at. That is the 0 position, right? Okay. So since in our header file we allocated the memory 512 kilobytes, so just that's why like it says 512 kilobyte. Clear? So now the very first line, if you so those files I already uploaded to your UMlearn, you can have a look also. So the very first line, that is insert object 100, right? So 100 is kind of the size, okay. So now what will be our head? Head will be pointed to a node now, because we said it's working like a linked list, right? So what are the fields we have? Like the number of bytes, the size, you can also assume that this is the size is 100. Start address is 0, reference is 1, right? And count is also 1, right? Here, okay. So now we have a for loop. If you look at the main file, we have a for loop, right? So for sure the buffer, whatever it currently pointed at the very start position, right? Here, and now we have a for loop, right? So in the for loop, actually we are just what we're doing. Maybe we can go to the file again. So we are just saying this, right? So it's kind of it's just filled with A, B, C, D like that. If you look at the code, okay. And then we have the another one. It's called insert object 4000, right? Okay. So it will add another link for sure, right? So the size is 4000. We know that the previous one end at 100, right? So that's why this start address will be start from 100, right? The reference is 2 here, right? Okay. And we have the count is also 1. So count means like how many times is just using. Clear? So what we have, so next time we have another line, that is insert object with very long number, right? So so here actually you can see that we are just allocating the portion of the memory just like the before, right? Okay. So now whenever we have this drop reference, you know that we are not using that anymore, right? If you look at the code, we have a drop reference and it's pointing ID 3. That means that the one we just created, we are just dropping that. Clear? And now, so it will be updated like this, right? And now we have another one, right? So we cannot assign that one here because we haven't freed that space, right? Clear? So rather than we are using these spaces, right? Same way. Okay. So here actually reference kind of, you know that it means like the node number kind of. Okay. So what we're doing now, we have a for loop and print, right? Okay. So now whenever we are finishing these main function, you know that we have enough to allocate memory and hand it out, right? But what if like we don't have enough memory, but we have some unused space? Okay. What we need to do? We need to free up the memory that we are not using, right? So maybe I will start discussing these things from Friday class. Okay, so we'll see like this is called the fragmentation, right? You have something unused portion in your memory and how we can defragment it. So that's our Friday's topic. So maybe I will stop it here, but I am available here in Cisco. Like if you have any kind of question, you can ask me in the chat. Okay. What does count represent? Count is kind of an ID. Like count means count is actually here count is so maybe I will update this slide because whatever we're saying reference, okay, so that's actually it should be so count is working as a reference, like how many times it is calling, okay. So that's why like whenever we cross it out or we're dropping, we're saying count equal to 0 because no one is using this one. Here reference is actually just is like the node number or something like that, and count is representing like how many times it is using. Is it clear, Michael? Okay, so one of your friend asked like what will be the type of question. It will be it's not fixed yet. I will discuss it in your very last class for sure. Okay, like in the very last class I will go for the final exam review for sure, and then you will get better idea like what kind of question you have. It can be multiple choice question, it can be short question, it can be long question even. You need to you have to you maybe you need to write some code. Okay, so still it's not decided. I will maybe I will explain it more later. So Emmanuel asks, is the exam going to be easy? What do you think? Maybe for you it will be easy because you are expert, right? So who is like that doing the lab, doing the assignment, and just follow the lectures? For them it will be easy for sure. Yeah.
Right.
Yeah. So I will just create some appointment also for today. Okay. So if you guys need any help for assignment or if you have any questions, since I missed the last like Monday office hour, you can just like choose the appointment to meet with me. So let's not discuss like whether it will be easy or not. Let's discuss like how we can know more things or how we can be an expert in C language, right? So it will be better. So will the 6 cancel lessons make the course harder to keep up with? Not really, because what I'll do if I see that so the thing is that there is no bound how far we can go, right? So in C, like the basic things we already kind of covered. So we are kind of jumping into advanced things, right? So whenever I saw that I missed some classes, what I will do actually, like rather than like missing those advanced topics or like there are some topics that actually not reflect your future career, so maybe I will just maybe omit just one topic and that will be better. And if I see that uh, I need to post many lectures, like I can just like upload the video lecture for that topic also. Okay, is it clear? Any more question?
Is the exam gonna be easy?
Yes, for sure. For you.
Thank you.
Yeah. It goes based on yeah. So yeah, it's really unfortunate. Yeah. And anyway, so for assignment, so another one, so will you change the marking scheme? So far, no. I'll let you know if I do. Yes, for assignment number 3, if you read the question, you should make the make file things.
Are you gonna be are you gonna be shifting grade?
It's not clear. Can you just write in the chat box?
Okay.
It should work with make, yes. I mean the command word make, not clang stuff. I'm not sure like what do you mean by that. I mean the command word make, not clang stuff. I'm not clear about that question. Can you just rephrase it? Are you gonna be shifting grades? For now, no, because we are still like everything going on a schedule, right? Like we are not missing any like lab or assignment. Also, we can assure that HW3, that means assignment 3. Can we assume that yes, but also it's interface implementation things, right? Yeah, we discussed it previously actually. Like it's not about only linked list things, it's about like how we can hide the implementation details, right? And using the interface, right? So in the main function, like in the test function, you are only using the interface things, right? Yeah. So do you have any other question? Then maybe we can end today's class. Okay. I'll see you guys on Friday then. Stay safe, everyone.
Good night.
Hello? 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 Hello?
Hello? Hello? Hello?
Hello?
Hello? अरे नहीं
Goodbye.
कर यार मतलब
Is
सर
the prof still in the chat?
yes he did.
Like, did he leave? Did he leave? Can you guys see my camera?